As I mentioned in the last video, I'd like to do the same problem again, only this time I'm going to avoid using this quotient rule. And the way that you can avoid using the quotient rule is by using our knowledge of indices to write the function in a different form that can be tackled by the product rule and the chain rule. What I'm going to do is I'm going to rewrite this function. Instead of writing it in this form as a fraction, I'm going to write it as a product of two functions, and the bottom one I'm going to write with a negative index. And you can see that this has turned this into a problem similar to the one we did earlier, where we had a product and a chain rule combined into one. Here I've got one function multiplied by another function, and this one here is going to need the chain rule. So to differentiate this without using the quotient rule, I'm going to take the first one and differentiate it. So I'm going to get 2x plus 7 multiplied, sorry, not the plus 7. Of course, it's just 2x, because the 7 disappears when we differentiate. First one differentiated is 2x, multiplied by the second part unchanged, plus the second part, actually sorry, we'll do the first part unchanged, just the way we were doing it before. Okay, differentiate the first part, keep the second part unchanged, plus keep the first part unchanged, times the derivative of this, and again the derivative of this using the chain rule. I bring the power down the front, negative 1, keeping that as it is, reduce that by 1, negative 1 take away 1 is negative 2, multiplied by derivative of what's in here, which is 5. And we can tidy this up. What I'm actually going to do is I'm going to get these negative indices back into the bottoms of fractions. So I'm going to write that as 2x on 5x minus 1 to the minus 1. Oh, sorry, not to the minus 1. Making a lot of mistakes in this problem. I'm going to write this as 2x over 5x minus 1, because the negative index indicates that it's on the bottom of the fraction, it's in the denominator. Plus, looking at this here, I've got three parts that are going to end up on the top of the fraction. I've got my 5, I've got my negative 1, and I've got my x squared plus 7. They're going to be in the numerator. So that's going to become negative 1 times 5 is negative 5. So it's going to be negative 5 x squared plus 7 in the numerator. And this part here is going to end up in the denominator. My 5x minus 1 squared, I've put it in the denominator, so it's no longer a negative index. Now, looking back up to what we had before, you can kind of see that this looks almost the same. We just need to do a little bit of tidying to make it look exactly right. What we need to do here is we've got two fractions, algebraic fractions. We need the same denominator. Both of them have a 5x minus 1 in them. This one has a 5x minus 1 all squared. So I need to get the denominator of this one to be the same, the first one to be the same as the denominator of the second one. So to do that, we're going to use the old trick we know. If I multiply this fraction by 5x minus 1 on 5x minus 1, remember 5x minus 1 on 5x minus 1 is just 1 in disguise. I'll write that over here to make the note. Anything divided by itself is just 1. So I'm really just multiplying by 1 here. It's not changing the value of anything. And here, looking at this fraction, I'm just going to expand as I go. I don't need to change the denominator. Looking here, I'm going to multiply the numerator and the denominator, so I'm going to get a 2x outside of 5x minus 1 on 5x minus 1 all squared. Take away 5x squared plus 35, 5x minus 1 all squared, common denominator, so I can just put them all over that denominator. I'll just scroll down here a little bit. On the left-hand side here, expanding, I get 10x squared minus 2x. Right-hand side here, remember this negative sign has to apply to both terms, so I get minus 5x squared minus 35. And gathering like terms, 10x squared minus 5x squared is 5x squared, minus 2x minus 35, all over 5x minus 1 all squared. And if we compare that with our answer from before, you'll see that it's exactly the same. 5x squared minus 2x minus 35, all on 5x minus 1 all squared. So in fact, we see we don't really need the quotient rule, but as I said before, it can be really helpful and it can save some working. Here we managed to do it in 1, 2, 3 steps. Here we had to do all of this working, and there was messy stuff with the denominators if we wanted to get it into a nice form. Although I guess technically you could argue that it is differentiated at this point here. It just doesn't leave it in a very neat, nice form for us to do other things with. So those are all of our differentiation laws.